Hey, what's up guys? This is a video for section 7.5, which is exponential functions. And we are going to start looking at a new graph that you guys have not seen before. And the name is exponential functions. So before we actually graph, we have to understand a few vocabulary words so you can understand how to graph the function. And you guys see some on the screen here. So for exponential function, when you want to graph, you guys maybe we have to transform the graph into a different graph. So transformation. The word transformation, it means the change in position, size, or shape of the graph. And I'm going to show you guys with the graph what is a transformation or what to expect when you guys transform a graph. And the second one is called the asymptote. When you guys graph an exponential function, the function is going to approach a line that is called an asymptote. So the asymptote is a line that the graph approaches infinitely but never touches. So those two lines in the graph will go to infinity, but they will never touch. At some point they look like they are touching, and I'll show you guys that in a graph, but mathematically they will never touch. Domain and range is not so new. You guys already know domain is your x values and your range are your y values. But when we want to state the domain and range in a graph, we want to know what x values work for that graph and what values work for that graph. So you guys need to get used to looking for the domain and the range for a specific graph. So what is an exponential function? You guys see on the screen two different functions or two different equations on the top. One is called the parent function and the other one is called the general function. Now, for a exponential function, the parent function is the most simple, easiest graph that you can have, and it looks like this one here. F of x equals b to the x power. Remember, keep in mind that f of x is also y, so you can have y equals b to the x power as well. So they both are the same thing, but this is the most simple, easiest one that you guys can graph. Now, this parent function can be transformed or change into a general function. Now, if you look at the difference, we have f of x, b to the x power here, and over here we have more things next to the b. We have f of x equals a times b to the x minus h power and plus k at the end. So the difference is this one doesn't have an a, this one doesn't have an h, and this one doesn't have a k. Well, it actually has an a here, but we don't see it. It is an invisible one. So if people ask you, well, what is the a value here? You can say 1, but mathematically a has to be greater than or less than 1. But we don't have an h and we don't have a k here. Now, what do they stand for if you have an a, h, or k? The a is going to be a number, the h is going to be a number, and the k will be a number. The base is also a number, and it can be a fraction or a whole number. But the a value, it means it's a vertical stretch or compression. Vertical means up and down, and stretch is when you guys stretch up and down the graph. So the graph is going to become a little bit skinnier, and I'll show you guys that in a minute with the graph. So it's going to be a little bit skinnier if you stretch it vertically, or if you compress, that means you guys make the graph go down and up, so it's going to be wider. If the a is negative, that means that it's a reflection over the x-axis. What does it mean? If you look at the picture here, we have a graph of an exponential function. That's the shape. It's a curve, not a line. It's going to be reflected over the x-axis. So we know the x-axis is here. So this one is going to be on the bottom of the x-axis. It's going to be reflected just like a mirror. It's going to be kind of like the opposite of the original graph. So it's going to be reflected on the bottom. That's your a value. So a tells you a couple things: vertical stretch or compression, and if it's negative, you guys have a reflection over the x-axis. Now h, the number here, you have x minus h, or you might, for example, you might have x minus 2, or you might have x plus 2. Now for h, you guys always want to change the sign. So when you are asked what is the h value, if it's minus 2, you will say positive 2. You have to change the sign. Now that right here tells you it's an horizontal translation. Horizontal means sides from left to right. Translation means you move steps to the right or steps to the left. So you are going to take this graph. Imagine you can graph. I can kind of do that right now. I graph. Notice I'm moving the graph left and right. So that is an horizontal translation. And K value is a vertical translation. So vertical means up and down, and translation means you move up or down. So I'll give you guys an idea. You guys take the graph, and you guys can move the graph up or down like this. So it says here, for K value, the K value is at the end of the function, never change the sign. So if you have a plus 2, then K is positive 2. You have a minus 2, then K is negative 2. H, right here, guys, for algebra 1, we don't really use it. We just focus on the A value and the K value. But this is for algebra 2. When you guys go on to that class, you will use H. So I'm just giving you guys a heads up of what you are going to use in the next math class, algebra 2. So let's look at the picture. So the picture here, you guys have the curve, and it's going, if you look at the graph from left to right, it is going up, it's increasing. That's what we say. The graph is increasing because it's going up from left to right. And the asymptote is the x-axis when you guys have the parent function. Notice the function here. I'm going to highlight it. The parent function is f of x equals b to the x power. So for the parent function, the asymptote is the x-axis. So if you look at the x-axis, notice the graph right here. It's getting if you go this way, it's getting closer and closer and closer to the x-axis, but it never touches. I know at this point, it looks like it's touching, but mathematically, they are not touching. So the asymptote is just that line that it will never touch. Notice that the parent function also crosses 2 points, and that's what we're going to use to help us graph the function by hand with no calculator or no graphing calculator. So the parent function crosses 0, 1, and 1b. Now this is increasing, so 0, 1 here, and this one can be 1, 2. So I'm just making up the number for b. So 1, 2 here. Now what's b? Your base is the number with the exponent right here. So you guys can see b can be a fraction, it can be a number, but it tells you guys for the second point, you use 1 and b, and this is for the parent function. If you guys have an a or a k, that's going to be different because that's transformed when you guys have an a and a k value. So what do you guys need to look for? Let's go to the next slide. You guys will have two options. The first option is if you have an exponential growth. So the graph is going to go increasing like this. Now, how do you know it's an exponential growth? Well, you look at the function, and if the base is greater than 1, the number with the exponent is more than 1, we say it's exponential growth. And the shape is going to be like this, increasing from left to right. When you look at the graph, you start at the left side, and once you go to the right, it's increasing. If you guys have the base between 0 and 1, so that means less than 1 but more than 0, that means it's exponential decay. Decay means decreasing. So if you start the graph from here, from the left side, it's going down, it's decreasing. So you guys have exponential decay. The asymptotes, you guys see the red line here. So I know that it looks like they're touching here, but mathematically they're not. And I'll show you guys that in a second with an actual app. But it is they're not touching, and I'm going to have you guys do a dash line. I know I have a solid line here, but I like to see a dash when you guys graph by hand. So how do you know which graph you have? Well, look at the b value. Once again, exponential growth, the base is more than 1. Exponential decay, then you guys have the base less than 1. All right, so how do you actually graph a function? You guys are going to look for a few things. The first thing you need to know is if it's exponential growth. So that's the most basic thing that you need first. The second thing is you are going to look for the asymptote. Now the asymptote, you guys will need an equation, and it is going to be an horizontal line, but the equation for the asymptote is going to be y equals your k value. The k value is the one at the end, and if you guys don't have a k value, it's going to be 0. So you guys have y equals 0. So if you have a k, let's say a plus 2, then you guys will have a positive 2, y equals positive 2. For the parent function, you guys will use 0, 1, and 1b for your 2 points. Once you guys find those 2 points, you guys will connect the points, and depending if it's exponential growth or decay, you guys will make your graph. I forgot to mention, you guys will also have to make a dashed line for your asymptote up here. So you guys will get really close to the asymptote but never touch. Now, I might be asking for the y-intercept once in a while. So one way to find the y-intercept is if you take the point 0 and then you have a plus k. If you don't see an a, we are going to use 1 for a. And then if you don't have a k, we're going to use 0. So you might have 1 plus 0, or you might have 1 plus 2 if k is 2, or whatever those numbers are. You guys would do that summation, and that's going to be your y coordinate. So the y-intercept is 0 for the x, and then you guys would take a, the value of a, plus the value of k. Now, domain. Domain for exponential functions is all real numbers, which means that any x value works in that function. If you plug in an x value, you will get a y value. So it works. So all real numbers work. The range are the y values. Now this one, it depends on the asymptote and the graph. But you guys might use y is greater than k. K is the same one as the asymptote. Or y is less than k. And once again, k is the asymptote. If the graph, for example, in this one here, if the graph is on the top of the asymptote, so here's the red line, the asymptote, and the graph is on the top, we are going to use a greater than. Y is greater than x. But if the graph is on the bottom of the asymptote, we're going to use a less than. So I'm going to show you guys examples of graphs before we actually graph it by hand. So let me just show you here with Desmos. And you guys will go to desmos.com. So let me just put here www.desmos. This is just a free app that you guys can use, and you can start graphing any different functions. So let's go ahead and look at a couple of functions, exponential functions, and understand what you guys need to look for. So I'm going to start with a simple one. I have y equals 2 exponents of x. Remember that your exponent button is right here. And the x and the y are over here. So that's the function. The function you guys see is exponential growth. Why am I saying growth? Because my base, let me go back here, my base 2 is greater than 1. So when you guys look at the graph, we have increasing from left to right. And when you look at the x-axis right here, the graph looks like it's touching at this point, but mathematically they're not touching. I'm going to try to zoom in to show you that they're not. So I'm going to, let me try something here, and it's not working. I'm trying to use the app. So I got the app working, and I'm zooming in here. So notice that the lines, they're separating, the red line and the black line, the x-axis. If I zoom out right here, well, it looks like they're touching, but when I zoom in, they're separated because they're not, mathematically, they are not touching. And you guys can go all the way over here on the graph, and you guys can try again. You can zoom in and notice that when I zoom in, they are not touching because that is your asymptote. So let me go back here to the beginning. I'm just going to press the home button. Hopefully this works. There we go. So you guys have exponential growth. Now, let me show you guys one when the base is less than 1. So if it's less than 1, let me try y equals, and I'm going to use parentheses 1/2, so that is less than 1, close parentheses, exponent of x. So look at the direction now. The direction of the graph is going the other direction, okay? So we have something from up here, and it's decreasing, and it's going to the right. So this is exponential decay because the base is less than 1. I use 1/2. Same thing with the asymptote. With the asymptote, you guys can see that the graph is actually not touching the x-axis, because mathematically it's getting closer and closer and closer, but they never touch. So for exponential growth, exponential decay, you guys do have an asymptote. You guys will make a dashed line, and then you guys will make 2 points, and you graph the points. Make sure you guys know what type of exponential function you have, exponential growth or decay, because that's going to help. And one more thing I want to show you is when you have a negative a or a negative in front of the base. So if you guys look here, we have an exponential growth. I have 2 functions, but the one that's on the graph is your exponential growth, because the base right here is more than 1. The base is 2. Now the second function, y equals negative 2 to the x power, very similar, but one is negative, the other one is not negative. It's just 2 to the x power. Well, you guys need to see what happens with the negative a value. And I'm going to turn on this function. Right now I have it off, but I'm going to turn it on so you guys know, see the difference between exponential growth and when the a is negative. So let me just turn this one on here, and you see the second one, which is the blue one. So when you guys compare the two, the red one is no negative, so you just have y equals 2 to the x power. But when you add a negative to that number, it's actually going the other direction. So that is a reflection across the x-axis. Let me put this over here. So this graph was reflected over the x-axis, and it's actually the opposite. If this is going up, when you reflect it, it's going down. Even though it's going down, guys, we do not say it's exponential decay, because the actual base is 2. So more than 1 means exponential growth. But the negative is what makes the graph reflect over the x-axis. So now you have the graph under the x-axis, and it's going the opposite direction. So those are the things you guys need to know. You need to know if it's exponential growth. If you have a negative, it's reflected across the x-axis. If you guys have k value, you will move the graph, and I'll show you guys that on my second video, because I'm going to have to make a second one. And then you guys are going to graph with no calculator. Okay, so let's look at a couple of examples here, just to make sure you have to graph the parent function, and then I'm going to show you guys when you guys have the k value and the negative in front of the base. So this function here is just the one I show you guys in Desmos, but now we have to understand how to graph it by hand. So f of x equals 2 to the x power. This one, f of x, is the same thing as y, so you guys can also have y equals 2 to the x power. It is the same thing, but you guys need to graph it. Now, how do you graph it? First, let's understand what type of function we have. So this is exponential growth because my base is 2, so more than 1. It is exponential growth, and I'm going to write that down so I don't forget. So we have exponential growth. So it is increasing from left to right. My asymptote is the number at the end of the function, which is the k value. So here, after the x, notice there's no number. So we don't have a k value. So that means k is 0. And I'm just going to write that down right here. K equals 0. So my asymptote is going to be y equals 0. That's your asymptote, y equals k, 0. Now, for the points we use, for the first point, we have an x value of 0, and the second point, the x value is 1. Now, if you guys do not have a k value, you just have the parent function. We don't have an a as well because there's no negative in front of the 2. Sometimes you have a different number multiplying the base. So this one here is just a, you guys can say it's 1, but we have just the parent function. So the points, when you have just a regular parent function, the first point is going to be 0, 1, and the second point is going to be 1 and your base. Now the base is 2, so that's what we use, 1, 2. So let's go ahead and grab those two things. Number 1, the asymptote. The asymptote is y equals 0. 0 is right here. the origin. So that means you have the asymptote going from left to right and it's crossing the origin. I'm going to make a dash line, and I want you guys to do the same thing in my class. You guys make a dash, and that represents our asymptote right there. Then you guys are going to plot the points. So 0, 1, regular points, just 0 and then 1 up. 1, 2, 1 to the right, 2 up is right here. And now you are ready to make your function, your actual graph. Now remember, this is exponential growth. Growth means that it's increasing from left, it goes like this, and then increases, it goes up. But remember that the asymptote would never touch the graph, or the graph would never touch the asymptote. So what we do is we're going to start with really close to the asymptote on the left side right here. You guys are going to go to the right, and once you get closer to the points, you're going to start making your curve. It is an exponential growth, and you connect the points. So that is the graph. You guys have the graph close to the asymptote. Now this is not perfect. I know it's not perfect, but it's not touching the asymptote. And then it's increasing. Once you get to those points, increasing, and it goes up. So that's the graph. Now the y-intercept. The y-intercept, you guys can see the graph. You guys can check. The y-intercept is right here. It's 1, positive 1. But as a point, we say it's 0 and 1. Now remember that I told you the y-intercept is a plus k. You have a 0, and then we have a plus k. Well, remember k is 0, and a is an invisible 1. 1 plus 0, 1. So you guys can also do that, or you can look at the graph and find the graph. Now for the domain. When you have an exponential function, domain is all real numbers. So I'm just going to write that down. That means that all the x values work. The graph goes this way to the negative numbers. So it is a negative infinity. And then it goes this way to the right, and it keeps going up to the right, and it's the positive infinity. That's all real numbers. For the range, you will have a y. Now you look at the graph, and to know if it's greater than or less than, here's the asymptote, and the graph is on the top of the asymptote. So we use greater. If it's on the top, it's greater. If the graph is on the bottom, it's less than. Now what's the k value? What's the asymptote? 0. There's the k, 0. So you have y greater than 0, and that is your range. So we have an exponential growth, exponential function, and you know all the components. So let's try one more. This one is an exponential decay. Exponential decay because the base is less than 1. I'm just going to highlight it. 1/2, that is less than 1. And let me just write this down here. We have an exponential decay. Now, I'm going to look for the k value. The k value is after the x, so right here we don't have a number. So k is going to equal 0 again in this graph. So my asymptote is y equal to 0. Now for my 2 points, remember, if you don't have a k value or an a value, you guys will just use 0, 1, and 1, and the base. Now the base is a fraction, so we have to graph with the fraction 1/2, and that's no big deal. I'm just going to show you guys 1/2, just in between half. But let's go ahead and do the asymptote, and let's plot the points. So the asymptote is 0, so that means that on top of the x-axis, it's going to cross the origin right here, 0. So notice my dashed line, that is my asymptote, so the graph is not going to touch that line. And my points are 0, 1 right here, and then 1, and then you guys go up. So here's the origin, 1 to the right, and then you go up halfway, 1/2. So that's in between, right here. So we have the second point, and remember this is exponential decay. So decay means you are going to decrease. So the way you do it, guys, you're going to start up here and decrease, and I'm doing my point right here. Not a point, I'm going to start my graph. You can start kind of not too far away from the y-axis, but more or less right here, and then you go down, decrease, because it's exponential decay. You connect the points, and you get closer and closer and closer to the asymptote, but you will never touch. So I'm just going to start from here. You guys go down, and notice I'm trying not to touch the asymptote. So we have the graph. Exponential decay because it goes down. Now for the y-intercept, you guys can see the y-intercept is again 1, 0, 1. So I'm going to write that down, 0 and 1. Domain for exponential functions is all real numbers. So you just write that down because the x's, any x will work. You guys can plug in any x into the function and it's going to work. But my range, let's go ahead and look at the graph. So we do have a y here. The graph is on top of the asymptote. So the red line, the dotted line, dashed line is your asymptote. So the graph is on the top. So that means you guys have a greater than top. When the graph is on top of the asymptote is greater. And my k value is 0. My asymptote is 0. So I'm going to put 0 for the range. Y is greater than 0. All right, guys. So I'm going to stop here. Check out my second video, and that's going to have when you have a value and the k value. So it is a transformation. We are going to change. We're going to make some change to the parent function. Make sure you look into that. And also, make sure you guys practice. And I'll see you guys later.